Consider a function u which depends on the position x and time t. The partial differential equation dou u by dou t is equal to dou 2u by dou x square is known as the wave equation, heat equation, Laplace equation or elasticity equation. Now we have to check this equation with the given options. Okay, that's the shortest way that we can do, and of course we are not going to derive all the 4 equations. So the differential equation given to us is dou u by dou t is equal to dou 2u by dou x square. Okay, so this is the given equation. It's right here, given. Now first option given is a wave equation. Okay, so let's check here. Option A, wave equation. Wave equation. Now the wave equation is given by utt is equal to c square ux. The meaning of this equation is dou 2u by dou t square is equal to c square dou 2u by dou x square. Now of course if we compare this equation with this equation, this is not the wave equation. Okay, now let's check second number B, that is heat equation. Heat equation. Now the 3D heat equation, in vector form we can write it as Laplace of temperature plus Q by K is equal to 1 upon alpha change of temperature with respect to time. The meaning of this delta square T, or we call it nabla actually, but we also call it delta. So delta square T meaning is dou 2 by dou x square, dou 2t by dou y square plus dou 2t by dou z square. Okay, so for 1D heat equation we can write dou 2t by dou x square plus, now if we consider the heat generation is negligible, that means without heat generation, we can take this term to 0 and we can write this as dou 2t by dou x square is equal to 1 upon alpha dou t by dou t, that means change of temperature with respect to time. Now if we consider alpha is equal to 1, so we can also write it as dou t by dou t is equal to dou 2t by dou x square. Now if this temperature, this t is the temperature here, if we can replace it with any variable. So if we consider t is equal to u, suppose u is the temperature, so we can write dou u by dou t is equal to dou 2u by dou x square. So if we compare this equation number 3 with, let's say this as equation number 1, so we see here this is a heat equation. So 1D heat equation. Let's write here itself. So this is 1D heat equation. That means one-dimensional heat equation. So option B is the correct choice. Now let's see option C here also. Option C is Laplace equation, and the Laplace equation, let's write option C, Laplace equation. Now Laplace equation is simply given by dou delta 2u is equal to 0. Okay, so this is Laplace equation, and which we know can be written like this. Okay, here I have already explained it here. Now option D is elasticity equation, right? Elasticity equation, which is of course incorrect here for this problem. So elastic equation is given by m by ei is equal to negative del 2 y by 2 square. So this is elastic equation. Okay, so from here we have already concluded that this equation is heat equation, and also heat equation from the classification of differential equation we can say heat equation. First let's say this wave equation. So the wave equation, this equation can also be classified as In partial differential equation, it can be classified as hyperbolic equation. Hyperbolic equation. And this 1D heat equation is parabolic equation. So not 3D, but 1D heat equation that we have derived here. This equation is parabolic equation. And the Laplace equation is elliptic equation. To understand these classifications of differential equation, you can refer to the NPTEL course, lecture number 5, classification of partial differential equations and physical behavior, computational fluid dynamics by Professor Suman Chakravarti of the Department of Mechanical Engineering at IIT Kharagpur.